All right, this very short video has to do with calculating resistance in a parallel circuit. Now, it will also work in a combination circuit, but you have to use it appropriately, and that means in the parallel only portion of a combination circuit. So in either case, it's the same parallel total resistance calculation. And it's what you see here in the top left corner. Total resistance, RT, equals 1 over R1 plus 1 over R2 plus 1 over R3. So we'll use as an example here our three resistors as 100, 200, and 300 ohms. So you see the resistances go down here, and I just place the ohms in to remind you that these are the three that we're using right there. And they are all in ohms, the base unit, so you don't have to do any conversions. So from this point on, I will just leave it out. So how you calculate this, you just look at the denominator of this larger fraction. So all of these numbers below the first larger fraction. 1 divided by 100, 0.01. 1 divided by 200, 0.005. And 1 divided by 300 is a 0.0033. Now that's 33 repeat. So there is going to be a slight error, a rounding error here. And I had mentioned these questions beg to be left in their fraction form. Now it does depend on the values of the resistor, how much excessive rounding you'll get, if any, when you convert to decimals straight away versus leaving them as fractions. So that is kind of question dependent, but still the best way to do these are actually to leave these as fractions, and that's over here. I'll show that in a minute. So when we add these three up, remember to do that first. Add these three up and get one bottom number, and then it's just simply you do with this fraction what you did to the smaller ones here. 1 divided by 0.0183, 54.6448 ohms. More than accurate enough for what we're doing. Now over here is the same thing with fractions, and all you do is make have a common denominator here. In this case, the lowest common denominator, to keep integers on the top, of course, is 600. So 100 had to be multiplied by 6 to get 600. So 1 times 6 is 6. You do the same thing for the 1 over 200. And in this case, you get 1 over, and then you sum these fractions, and it's 11 over 600. And what you do here is just 11 divided by 600, and it gets you this bottom number. And then you have just a straightforward fraction, not the 1 over 1 over. And you'll notice it's the same, and it divides out to the same. Now, actually, both of these numbers are slightly rounded, and they're rounded the same, so they came to the same number. But this is 183 repeat, just like this is, so the actual value, less rounded, is slightly different than this. But you'll notice in both cases, it does come out to, in this case, the same answer. But depending on the values you have, you may create excessive rounding going this way versus this way. So this is why I always say go out to 3 and preferably 4, as you see here, decimals. You just want to reduce that rounding. And if you're going to do it this way, the rounding could possibly be worse. Although in this case, it happened to be the same. And that's all there is to calculating total resistance of a parallel circuit.